Hello, everyone, and welcome back. So we're looking at exponential functions. This question over here says, consider the function f of x is equal to 4 to the power of x plus 2 all minus 6. Without using a graphing calculator, determine the domain and range of the function. Now, how do I figure out the domain and range of this? Well, remember, an exponential function has the domain of, well, actually, let's first look at how it looks, right? We know that the exponential function looks like this. It could either look like this if it's decaying, or it could look like this if it's growing, right? So over here, this is growth. This is decay. They all have an asymptote, a horizontal asymptote at y is equal to 0. So over here, this is decay. Okay, so over here, the domain will always be x is an element of all real numbers. And so regardless of what I do, that will be the domain, whether I move it to the right, whether I stretch it, we'll always have that domain because it goes in both directions, right? And so my domain will still be x is an element of all real numbers. But my range, we know, is restricted. So my range initially for f of x is equal to 4 to the power of just x. My range was initially y is an element of all the numbers such that it's greater than 0. But let's see if it's moved up or down, right? Because if it's moved up or down, then that changes our asymptote. So over here, we can see that the entire function has moved 6 units down. And so if I've moved this y is equal to 0, 6 units down, then my new asymptote sits over here. And I say, instead of y has to be greater than 0, now y has to be greater than this lower asymptote, which is negative 6. So we say, okay, well then y is an element of all real numbers such that y has to be greater than or equal to negative 6. Oh, not or equal to, it doesn't actually touch the asymptote, remember. All right, so greater than negative 6. All right. Okay, so let's have a look at the transformations. So, sorry, the y-intercept. So the y-intercept of the function, well, remember the y-intercept, you just set x equal to 0. So over here, initially the y-intercept, if I set x equal to 0, was just 1, and it's always going to be 1 before any transformations. So this was they were supposed to be going through the same thing, but that's okay. This one, let's just say it was transformed and it moved up. Okay, so the original has to always go through 1 because anything to the power of 0 is 1. And so what we're looking at over here is the y-intercept. So if I was to set x equal to 0, I don't just get 1 because it's going to be 4 to the power of 0 plus 2. So I go f at 0 is equal to 4 to the power of 0 plus 2 minus 6. 4 to the power of 0 plus 2, that's 4 to the power of 2. That's 16 minus 6, which is equal to 10. Okay, so our y-intercept over here happens at f at 0 happens at 10. So our y-intercept is 10. Okay, all right, next one. The equations of the asymptotes of the graph of the function. Well, there's only one asymptote, which is horizontal. We don't actually have vertical asymptotes with exponential functions. And we already identified this. The asymptote moved down here. It became y is equal to negative 6. So just y is equal to negative 6 is the horizontal asymptote. Okay. All right. So that's pretty much it for this question, everyone. I hope that helped, and I'll see you in the next video. Bye.